Welcome to Walkabout the Galaxy, the evolving astronomy podcast where the science is universal, the opinions are personal, and the studio has relocated.
Ooh.
We are strange and down, the Astroquarks, also known as Josh Caldwell.
And Audrey Martin.
Coming to you from the new Walkabout studio at the University of Central Florida. Today we are bringing you Walkabout Light, a shorter version of our show with half the hosts, half the science, and half the stupidity.
And half the fat.
Half the fat. Remember to subscribe to us. It's a light.
Mm-hmm.
Light.
It's
episode.
It's not no fat. It's just half the fat.
Right. Remember to subscribe. It's not Walkabout Zero.
Right, exactly.
That would
because that's like fake sugar.
Yeah.
And we're not fake.
That would be completely devoid of everything.
That would just be empty space, yeah.
Remember to subscribe to us on Facebook, Instagram, and YouTube, and send us questions, suggestions, and compliments at wtg@ucf.edu. Today we'll talk about cave dwelling on the moon. But first, this episode of Walkabout the Galaxy is brought to you by Acronyms.
Okay.
From NASA to ESA, from JAXA to ISRO.
ISRO.
Simplify your life and your vocabulary with acronyms. Whatever your tastes, we have an acronym for you. From acronyms that sound like they should mean something but don't. Carbon in Arctic Reservoirs Vulnerability Experiment, or CARV. Lunar Atmosphere and Dust Environment Explorer, or LADY. And the tried and true Low Earth Orbit, or LEO. To those that actually work, contrived though they may be. Mercury Surface Space Environment Geochemistry and Ranging, Messenger.
I like Messenger.
To those that will confuse your non-nerdy friends, MoMA is not just the Museum of Modern Art, but more importantly, the Mars Organic Molecule Analyzer. There's an acronym for every need. Mention Walkabout the Galaxy to get 3 acronyms for the price of 2 acronyms for the benefit of all.
That's it? The benefit of all?
That's what was...
Is that the tag?
So much of what I just did was disappointing on so many different levels that I'm not sure what "that's it" is referring to.
What was the tag?
For the benefit of all.
Oh, God. Well, that could be anything.
It could be, but it isn't.
Campbell's soup.
Or perhaps something with an acronym that's kind of like related to Walkabout
NASA.
the Galaxy. Yes.
All right. Second guess.
That's a good leap. That's like when
From Campbell's soup to NASA.
That's like when your first Wordle comes up with everything gray and there's no letters, and then you get it right on the second one.
Yeah, that happens to me all the time.
So, because you cheat?
No.
Because you put your first guest in. Your first guest is zebra, and then you say what's the answer, and you Google it.
Yeah.
Okay.
That's not how everybody plays?
I don't know.
You tell us, listeners.
Space news. Starliner is still docked with the International Space Station.
Right.
And it appears that it will remain thus for a few more weeks.
At least. Yeah.
Sort of month-long kind of time frame to the middle of August.
Yeah. It looks like they've been doing tests and they kind of understand what happened and they have some thrusters up and working now.
I think most of the thrusters are working.
And
what they're doing is they're testing their what we call engineering models on the ground. So they've got copies of everything that's in flight here on Earth.
So smart.
And they are running those through their paces, both, I'm presuming here, based a little bit on my own experience with mission operations and anomaly investigations. You have your flight, you have something going on up in space, like, what's making it do that weird thing? Let's see if we can replicate that behavior with my exact copy of that thing down here on the ground. Then you understand, it's doing that weird thing up here because this wire is bent, or this nut is loose, or whatever the case may be. And then when you've done that, you're like, okay, do I really need to worry about that bent wire or that loose nut?
Yeah, they did that with the solar arrays on the Lucy spacecraft when the solar array didn't fully latch. Yeah, they had a whole model of it, and they were trying it all different ways, and and everything's fine now.
But it never latched.
But we're confident that it won't snap.
It's just gonna be okay.
Yeah, because of the model.
Checked everything out and saw that the normal operating procedures isn't going to have it do something wrong. And that's what they're doing here. So that means the two astronauts that went up there are getting some bonus nights in space.
Yeah, it's got to be getting really crowded.
I think there's a pretty good group up there on the space station at the moment. Speaking of space station news, related, the Falcon 9 had an anomaly, if you recall, recently. So SpaceX's workhorse satellite launcher, the upper stage, had a fuel leak. There's some pretty cool videos of that. Sort of, it comes out, and I don't know what state of matter it goes into, but I'm assuming it's some sort of solid. It doesn't look like it's completely vaporizing. And that's not good. So the Falcon 9 is grounded for a bit. I don't think that'll be very long. There's actually a news conference today where they're discussing their plan for a return to flight for that. But I mentioned it in conjunction with the space station because Falcon 9 is supposed to take up the module that will sort of steer the space station to its ultimate demise in the Pacific Ocean at some time in the future.
Is that date set for its demise?
Certainly not a specific date, but it's in the vicinity of the year 2030.
Oh.
So 5 or 6 years of operations of space station still ahead of us. And that could potentially get extended. I don't know. That's based on, well, budget for one thing. So you have to keep paying for things, but also the rated lifetime of the components that are up there. Like, are you sure that the pressure vessels are still good, that the welds are still good, that the electronics are still good? At a certain point, if you start seeing multiple failures happening and you're spending all your time repairing things, that's probably time to go home.
I feel like there's always something breaking down, though, on the ISS.
Well, that's just generally true of the universe in general.
Fair enough. That's
it's kind of one of the worst things about the universe is that things are always breaking down.
It's always breaking down.
Yes.
Yeah, I guess that's fair. And also, when I see big news headlines, it's like, oh, a micrometeorite just went straight through the ISS. And you can't really predict that.
Not for a micrometeorite, but for the bigger stuff. And they actually had a little bit of a scare up there because there was a satellite disruption, and they all went and hunkered down actually in the Starliner as their sort of safe house. Yeah.
Oh, well, recently, obviously it would have had to been.
Right, because it hasn't been up there very long. Yeah.
Did they all fit? How many people are up there?
I don't know how many are up there, but it's...
there's got to be 10 people up there.
It might be 9.
9?
8 or 9.
And they all fit in the Starliner? Oh, my God. I just imagine the smell.
I don't know how long they were in there. But speaking of larger meteorites, a daytime fireball was observed over New York City yesterday.
Really?
Yeah. There's some cool videos of that on YouTube also.
I just don't pay attention, I guess.
You need to spend more time looking up.
I sure do.
Yeah. Probably the object was about 30 centimeters across, so about a basketball-sized object. And pay attention to this, Audrey, because our trivia is based on this
basketballs.
Event.
Okay.
Yeah, and in fact, since this is a Walkabout light, we're going to talk about the cave dwelling on the moon. But let me go ahead and give you that trivia now to ponder. Okay. And then you can tell us all about cave dwelling on the moon.
Okay. I'm nervous about the trivia because it's just me. So I can't have someone else go first. You can't
have somebody else do worse than you do.
Exactly.
Right. But also, you will win.
Okay. Thank you for the encouragement.
If you collected all of the extraterrestrial matter that lands on the Earth over the course of a year, so there all this material that mostly burns up in the Earth's atmosphere, it's mostly small stuff like grain of sand up to pebble-sized things. They come in, they burn up. We see it as a shooting star or a meteor. If you took all that stuff, all that material, collected it for a year, and you put it together in a giant ball or a small ball, you tell me.
Oh.
You put it all in a ball, and let's give it a density of 2 grams per cubic centimeter. So that's twice the density of water, similar to some lightweight rocks like maybe chalk or some limestone,
like
or maybe more than talc, but like limestone or
chalk
sandstone.
Is talc.
Is it?
Yeah. Right?
I don't know.
I'm pretty sure chalk is talc.
Okay.
I'm going to Google that.
Then why do we have 2 words for it?
There's multiple words for so many things.
Okay. In any event, a normal sort of low density rock, not iron, okay, not a solid chunk of marble, but a rock that you might pick up on the
got
beach.
It. Yes, got it.
How big would that ball be?
How big would it be?
Yes.
Oh, okay.
Okay, that's your question.
I'll get that.
What's the equivalent size of the thing that hits the Earth each year in stuff from space?
Okay.
All right?
Okay.
So,
cool.
The moon.
The moon. So there's these really cool things on the moon. I learned about them kind of recently, but they were discovered a while ago. They're these kind of giant pits.
They're very cool looking.
They're so cool.
They look fake.
They do look fake. And it's exactly like whatever you're imagining in your head is what it is. It's a pit. It's a circular
It looks like
hole
it looks
in
like
the ground.
aliens came in with a drilling machine.
Yeah.
And drilled down 20 or 30 or 50 meters or something.
Yeah, and a lot of them are like very circular too, so
Right.
it really does look kind of fake.
And with like vertical walls is the thing. Like
Yes.
the crater is very circular, but it's shaped like a bowl.
Right. And there's
sort of like
and there's ejecta as well, so like you
Yeah.
can see like, oh, there was something that
Something hit it.
happened,
Yeah.
but like with these pits, there's no ejecta around it. So
Right.
it doesn't look like it formed from being hit by anything from above. And
so so before we talk about this new result, where do these pits come from?
right. So we see these types of features on Earth as well in association with lava tubes, which are really, really cool. And it's basically just a cave made out of lava. And it forms when there's lava actively erupting from like a volcano and lava is spewing away from the volcano. The outside of a particular channel of lava will harden and
Cools off.
It cools off and it
But
hardens.
the inside is still hot.
And the inside is still very hot and fast. And so it's going through the tube itself, and it kind of also starts to sink into the ground. So it's carving out a tunnel below this hardened shell and is sinking and still going until the volcano doesn't have any more lava to spew. And then it empties out and you're left with a long tube, an empty tube.
An empty tube underground.
Yeah, and
Pretty amazing.
they're all over Earth. I've been in multiple.
Oh.
I went in one in Iceland. That was really cool. And there's one in Flagstaff.
Oh.
I know. It's
Well,
like it's
I think
really
I maybe would
fancy.
have started with a Flagstaff and then said Iceland.
Well, okay, that's fair. But chronologically,
Okay.
which is the most important thing.
And I think there are some in Hawaii as well.
Yeah.
You can go-
Anywhere where there's like basalt, which is the rock that forms from lava that cools off.
Yeah.
So in lava tubes,
does it feel like that tube in the Star Trek episode, The Devil in the Dark, where there's this silicon creature that carves out these perfectly circular tunnels underground?
I don't know. I couldn't tell you.
Okay,
I don't know that episode.
Does it feel like a very circular,
Yes.
super
They're
smooth walls? and kind of
They're
thing?
really cool. And you can see like the flow lines on the side of the walls too, where the lava flowed. And there's like a very clear channel in the center where it's almost like a road, it feels like, depending on how old the tube is and everything. But
Cool.
for a lot of these tubes, especially if nothing has come and been deposited on top of it later, holes can form in the ceiling of the tube, and they're called skylights. So if you're in the tube,
Yeah.
sometimes you can look up and see the sky. So it's a skylight. And the idea for these pits on the moon is that they are skylights
Of lava tubes.
on the
I
moon.
see. Okay.
Yeah.
And they may have been produced maybe an impact or maybe just it broke.
It was just a little thin
thinner
there.
right.
Yeah, something
so
like
then,
that.
if in that case, then there would be a pile of rubble underneath the skylight perhaps.
Right. Yeah. And depending on how thick the ceiling was, it might be a big pile of rubble or it might be a small pile of rubble. We don't really know. Okay. But the new thing with this new study is that some people used radar data to see if the pits are actually in association with tubes. So we haven't really discovered any tubes. They've been hypothesized on the moon, but they haven't been verified.
In other words, we're like, okay, here's a circular pit. This looks like I'm looking down the skylight of a lava tube like we see on Earth. But what is to the left and right of that skylight? Is there actually a tube that is empty of lava? And, besides just sort of an intrinsic interest, there's a very practical interest in that because the moon is a harsh mistress, to quote Robert Heinlein, I believe.
Cool.
And it's not a great place to hang out if you're a human being.
No.
From a health standpoint.
No.
Maybe from a sightseeing standpoint, but from a health standpoint, not great because there's no atmosphere or magnetic field to protect you from all the nasty photons and charged particles coming from the sun and elsewhere in space. So, if we're going to go back to the moon and kind of like an extended period of time,
it might be cool to hang out in a lava tube for a while.
Yeah. Maybe that's your base of operations.
I think that would be really cool, but I would also be terrified because
what
of
if
collapse.
Another skylight?
Yeah.
Right.
Like I don't know. I just, and the paper goes into, so because the moon, there's less gravity on the moon, and so these tubes can get bigger or can be bigger. They can form bigger. So on Earth, I don't remember what the number is, but the maximum like diameter of a lava tube maybe is, I don't know, like what's the size of this room? Like
10, maybe not even 7 meters or something.
Yeah.
And how big were the ones that you were in?
Pretty big, probably maybe like 15-ish meters was the biggest.
Across.
Yeah, was the biggest. And so these on the moon are thought to at least be able to be bigger. It doesn't mean that they are bigger, but they could be bigger. So I don't know if that makes it any better, but
so what the new result is that they have used synthetic aperture radar, side-looking orbital synthetic aperture radar.
Yeah.
Where they used the Selenological and Engineering Explorer, which collected data in 2009. Selenological. Selene being
S-E-L-E-N. The moon. Yeah. Okay.
Selene. And this is one where the acronym sort of makes sense. Which
Selenological is an acronym?
No, but the acronym of the Explorer is Selene.
Oh.
Because Selenological and Engineering Explorer, you can kind of smush that together to make Selene.
That makes more sense.
In any event, combination of that with Lunar Reconnaissance Orbiter camera data have confirmed that there is a left and a right. At least one pit. And interestingly, it's the Mare Tranquillitatis pit. So in the Sea of Tranquility. So it's only a couple 100 miles away from the Apollo 11 landing site.
Super close.
Random coincidence there. And they basically, what radar images do that's different than our typical sort of photographic images is you're shooting long wavelength light, and it bounces around in a different way. When you take an image, you're seeing the reflection of sunlight off a surface, and it comes straight back to you in a straight line. The radar can bounce around and propagate through things a little bit differently, so it can get into this side looking and sort of look down the pit at an angle.
Right.
And if you see it's bouncing around potentially in an extension in that lava tube, and if you get a return or not, suppose there is no left and right and there is no tube, you would get a certain kind of echo back, and if there is a tube, you get a different kind of echo back.
Right. Yeah.
That
makes sense.
That is a simpler the simplicity of that explanation corresponds to the limited nature of my comprehension of what they actually did.
Yeah.
But I think it's basically correct. And so then you make a model of, a computer model of what that underground structure looks like, and you simulate these radar waves going into it, and you tune that model until it matches what you actually saw with the data. And the answer is, there's a tube.
That's so cool. Okay.
And
I don't know what I was thinking it was, but radar to me, you and Jim always rag on me for being a spectroscopist, but radar to me is like
radar to you is infrared spectrography to me.
Yes. I'm like, okay, I don't know, whatever. If you see it, good for you. I don't know. I don't understand it, but I am happy other people do it.
So they have a couple of models here. So the pit is something on the order of 130 to 170 meters deep.
Deep?
Yes.
Oh.
Quite deep.
Jeez.
From the lunar surface down to the bottom. They have two models, each of which has a rock pile in the center that's from this collapsed skylight.
That makes sense.
One with a sort of shallow rock pile, and then the conduit has a height, like a ceiling height in the tube of about 25 meters.
Oh, wow.
Yeah. So this kind of work, and potentially, hopefully, future exploration and observations, because there are 200 of these pits have been observed on the moon.
Right. And I think we said this kind of towards the beginning. Some of them have you can see the walls of the pit, which I guess would be like the ceilings of the lava tube, or it could be that there were other lava events that kind of stacked subsequent lava events. So that, just scientifically, that would be really interesting to study, just as a fun aside. But yeah, there's a lot of them all over.
Yeah. So these are, we talk a lot about humans going to the moon and the South Pole. I don't know if we know of any pits in the South Polar region.
I don't know.
The pits sort of tend to go with lava.
Yeah.
And the South Polar region is more sort of what we would call a highlands area of the moon, which is not these flooded volcanic plains. So that might be a potential mismatch in terms of sort of long-term habitability. However, these are potentially cool abodes to go to. All right, Audrey, it's time for you to win trivia.
Okay.
Uncontested. If you collected all of the space stuff that lands on or that impacts the Earth, most of it burns up in the atmosphere and then drifts down over a long period of time, and put it into a rock, a spherical rock, what's the radius or diameter of that rock over the course of a year?
Over the course of a year.
Yeah.
I'm going to say...
This is a tough one.
Yeah. I'm going to say a diameter of 50 meters.
You did remarkably well.
Really?
Diameter of 34 meters.
Oh, yes.
So that's pretty good.
I thought about it. I've read some IDP papers.
Good for you. Yeah. That's, that's, if we were doing mass, you would have been off.
I don't even,
felt like a
and also with
mass,
because there's different types of materials that hits the Earth, that makes it harder and stuff. I don't know.
Yeah. Anyway, good job. So
yes,
like a 35 meter diameter chunk of rock is added to the Earth every year of stuff.
Is it it
is added.
Well, I guess it's added.
Yep.
Yeah.
Yeah.
That's fun.
Yeah.
While we toss junk up into space, we're getting more stuff.
That's right. There you go.
I wonder what the net.
It's definitely a net gain. We're not offloading that much material.
Not yet.
Not yet. Yep.
We get the Falcon 9 up and running again.
Yeah. And the Super Heavy.
Just start shooting cars up, people up.
Right.
Let's get them out of here.
We did get rid of that one Tesla.
We did.
Yeah.
And there was a dummy in it too, I think, or You're not supposed to call it a dummy.
Mannequin.
Mannequin. Womanikin?
I don't know.
Okay.
While it may have felt like a full episode of Walkabout the Galaxy, it was just a walkabout light. But don't go light on our stars. Give us all 5 and we'll give you the universe.
Be sure to follow us on Facebook and Instagram to get all our updates. Subscribe to our YouTube channel and catch up on old episodes wherever you get your podcasts.
Our theme music was composed by Richard Jerusik. Production assistance provided by Logan Basinger. Thanks to our listeners in the north of England and around the world. We'll be back next time with a full crew of Astroquarks and a full episode. Stay safe. I'm Josh Caldwell.
And I'm Audrey Martin.
We're the Astroquarks signing off until the next episode of Walkabout the Galaxy.